Hello guys, welcome back to Code with Us YouTube channel. So we are with one more web series of operating systems by the Code with Us. So third web series of this operating system. So now we are going to discuss about the system calls. So let's get into it. So what is system call? A system call is the programmatic way in which a computer program requests a service from the kernel of the operating system on which it is executed, typically which is written in the high-level language, which is C or C++, mostly accessed by programs or via high-level application programming interface rather than direct system call use. So three most of the common APIs are Windows 32 API, POSIX API for POSIX-based system and Windows for Windows-based system, and Unix, including virtual all versions of Unix, Linux, and Mac OS, and Java API for the Java Virtual Machine, which is JVM. A programmer accesses an API via a library of code provided by the operating system. In the case of Unix and Linux, for programs written in C language, the library is called library C, which is libc, which is used for the Unix and Linux programs written in C language. We use this library, libc, for the system call calling. And coming to the next slide, we will see about examples of system calls. System call sequence to copy the content from one file to the another file. So from source file to the destination file, what type of examples of system call will be seen? Let's see. From source file, we need to acquire the input file name, and we should first we should acquire the input file name and write the prompt to the screen that is acquired, and we should accept the input by the destination file, and we should then require the acquired output file name from the destination file, and this should be accepted by the source file, the input. So from the, we'll acquire the output file name from the destination file, that should be accepted by the source file name, source file. So after that, source file should open the input. If file exists, then it should abort, or else create an output file. If the file exists, we should do those things in the loop. It loops again and again, and we'll read again the input from the file and write output until read fails. Close the output file and write the completion message to the screen. We'll write the completion message to the screen and terminates normally. This is what example of one process of sequence of system call from the source file to the destination file. This is one of the process of system call during from one source file to the destination file. And coming to the next, example of standard API. So as an example of standard API, consider the read function is available in Unix and Linux operating system. So the API for this function is obtained from the main page by invoking the command man read on the command line interface. So a description of API appears below. So we are using #include uni_std.h, a header file. Will having the return value of size t is the return value, and we will read the function name, and we'll pass the parameters like ft, void, buffer, and size t and count. A program that uses the read function must include uni_std.h, which is a header file, as this file defines size size t and size t data types, among other things. The parameters passed to read are as follows. Int d is file description to be read, descriptor to be read, void buffer, a buffer where the data will be read into, and size t and count, the maximum number of bytes to be read into the buffer. So the maximum number of bytes to be read from the buffer is the size t. On successful read, the number of bytes read is written. A return value of 0 indicates end of file. If an error occurs, the read value returns to be -1. This is the example of standard API. So coming to the next, system call implementation. A system call interface serves as the link to system calls made available by the operating system. System call interface intercepts function calls in the API and invokes the necessary system calls within the operating system. Typically, a number associated with each system call, which is system call interface, maintains a table indexed according to these numbers. So coming to the next thing, the system call interface, which invokes the intended system call into the OS kernel and returns status of the system call and any return values. The caller needs to know nothing about how the system call is implemented, just need to obey API and understand what OS will do as a result call. Most details of OS interface hidden from programmer by API, managed by running time support library, set of functions built into libraries included with compiler. Next slide. Coming to the relationship between the application program interface and the system call versus OS, let's see the interface. So first at the top, we'll be having the API, which is user application programming interface. And next system call interface is there. And next in the kernel mode, we'll be having the OS relationship. So OS. So coming to the, so first user application sends a system call which is open from the user mode, and this will be sent to the system call interface, and there from there it will call implement the open system call, and from the it will be sent to the kernel mode, and it will open the system call, and again it will return that system call, and even again the output will be sent to the user application. So for example, if we consider here, we need to open a file or read a file. User application, user will send, so open the particular file, for example, file.txt to be opened. So open the file.txt, it will be sent to the system call interface using the user mode, and using the system call interface, it will be read, and the implementation of that, it should come, right? So after, if you say file.txt, it will be coming to the kernel mode, and it will receive the input from the system call interface, and it will okay, we need to open the file, then file.txt will be opened, and this will return again the file will be opening, and this will be returning to system call interface with the opening file. System call will be returning, and we can view the application programming interface where the application user can view the file opened, which is file.txt. This is the relationship where this much process takes between the user and kernel mode between the system call interface, which is API system call OS relationship. This is the what API system call OS relationship, and next will be continued by one of my teammates.
Yeah, next part is system call parameter passing. What is system call parameter passing, and how it will occur, in how many types of system call parameters passing are there? Let's discuss now. So system calls occur in different ways depending on the computer in use. So often more information is required than simply identity of desired system call. So exact type and amount of information vary according to OS and call. So there are three general methods used to pass the parameters to the operating system. So let's see what are the three general methods that use it to pass the parameters. The thing is the simplest one. So they pass the parameters in registers. So in some cases, maybe more parameters than registers, and the parameters stored in a block or table in memory, and address of block passed as a parameter in a register. So this approach taken by Linux and Solaris. So the parameters placed or pushed onto the stack by the program and popped off the stack by the operating system. So block and stack methods do not limit the number or length of parameters being passed. So let's discuss the parameter passing via table. The passing parameters to the kernel for a system call must be performed differently than when using an ordinary function. So this is the system call. So this is because a system call is performed by the kernel itself. So which is typically runs in a completely different address space than the process which made the call. So thus it is not possible to simply place a system call parameters onto the process stack, as this will not be readily available to the kernel. So let's discuss about the parameter passing via table. Then let's store the parameters in a block or table in memory, and pass the address of a block as a parameter in a register. So this approach is used by Linux and Solaris, as we discussed before. So this means here the table, this diagram will explain that these parameters for call, here this is the user program. This part is a user program. So here the user program, the parameters are there for call, and this load address system call 30. So this is the register. This is the register. From these parameters, this will go into the first register. So this will load first into the register, and again it will enter into the operating system. So this part is operating system. So here the user parameters from table X, this one, from table X. So this part, so this place is the code for system call. So whatever the code which user sends to the operating system, that code is available here. So this is the code for system call. For the system call, to which system it is called. So this is the code. And this will also from load here to register, from register to the operating system. So the process like this, the parameter passing in table. And the next one is types of system calls. Now we will discuss what are the types of system calls are available. So first one is the process control. The process control, it creates the process and it terminates the process. It will end the process, and it will abort the process also. So here another one is it will load the process, and it will execute the process. So it get process attributes and set process attributes. It will get the process attributes and it will set the process attributes also in system call. So it is for wait for time and wait event, signal event, allocate and free memory, so dump memory if error. So debugger for determining bugs, single step execution. So logs for managing access to shared data between processes. And the another one is the file management. The types of the system calls, in the second one is the file management. So it will create file and it will delete files also. So we can open the file, close files, and read the file, write the file, and reposition the file. And the last one, the get and set file attributes also. And the third type is the device management. Device management is a request device. It will release the device. It will read device and write the device and reposition the device. The file management, it will read the files, it will write the files, and it will reposition the file. In device management also, it will read the device, it will write the device, and it will reposition the device also. So in device management, it get device the attributes and set device attributes also. So logically attach or detach the devices. And the fourth one is the information maintenance. How it will maintain the information. The types of in system calls, it will maintain the information like get time or date, set time or date. So get system data, set system data, and get and set process, file or design device attributes. Sorry. And the final one is the communication. It will create, it will delete communication connection, and it will send, it will receive messages if message passing model to host name or a process name, like from client to server. And the next one is the shared memory model. It means it shared memory model, it creates and gain access to memory regions. It transfers status information, and it attach and detach remote devices. And the next one is, next type is, it's a protection. It control access to resources and get and set the permissions. It will allow and deny user accesses also. And let's see about the examples of Windows and Unix system calls. Like these are the types of system calls for process control, like which commands. Like these are the examples, like how to write the. So let's see, discuss for process control. So this is the type of system calls. The first type of system calls process control. For Windows, we have to write the create process. It means we want to create a process, so we have to write create process. For Windows, we have to write create process. For Unix, we have to write fork to for Unix, we have to write fork to create a process for process control. And exit process to exit the process which we are running. And wait for single object. This is for Windows. And for Unix, fork, exit, and wait. So next one is the file manipulation. For my file manipulation in Windows, we'll write the create file. We have to create file, and then next we have to read the file, and then write file and close handed. And for Unix, we have to write open, read, write, and close. So for device manipulation, next one, the set console mode, read console, and write console for device manipulation. And for Unix, it is IOCTL. And next is for read, and next one is the write. So for info, and next for another type, like information maintenance. For Windows, we have to write get current process ID, and then set a timer, and then sleep. For Unix, we have to write get PID, alarm, and the sleep. And the fourth type, communication, we have to write, for Windows, we have to write like create pipe, create file mapping, and map weave of file. So for Unix, we have to write pipe, SHM get, and M map for Unix. And for protection, we have to write set file security, and initialize security descriptor, and set security descriptor group. For Unix, we have to write chmod, umask, chown. So these are the examples that for Windows and Unix system calls. So these are the types. So thank you very much, and don't forget to watch the video. Please watch the video. Please do like, share to your friends, and subscribe to the Code with Us channel. It is very useful to you. So please subscribe to our channel. Thank you very much.